Chapter 8. Force and Pressure. Introduction. The ball starts to roll when we kick it. The speed of a ball rolling on the ground slows. It might alter its direction of travel. What causes an object to advance, travel more quickly, or alter its direction of travel? How is something in motion stopped? We pull a door handle to open it. We need to push in order to move in a swing. We must kick in order to move a ball. In general, actions like opening a door, taking up a book, kicking a ball, and dragging a chair are employed to describe specific events. The motion of the object is typically altered in some way as a result of each of these activities. Each motion can be classified as either a push, a pull, or both. Force. A force is a push or a pull on an item that tends to alter its condition of rest or motion. The direction of force refers to the direction that an object is being pushed or pulled. Typically, the letter F is used to symbolize force. Newton, indicated by the letter N, is the common unit of force. In our daily activities, such as pulling, pushing, lifting, stretching, squeezing, and pressing, forces are applied. These activities can all be classified as either pushes, pulls, or both. When a force is applied to a target, it is pushed, pulled, or flicked. Forces are due to an interaction. A force can only be applied when at least two objects are interacting. In other words, when two objects interact, a force is created. No force can exert its impact if there is no interaction between the two things. If a guy were to stand in front of a football, would the football automatically move in response to his presence? Now, imagine that the man kicks the football, exerting force on it. The football begins to move in the force's direction. Here, the football needs to be propelled by the one pushing it. Only the man in the example is able to exert force on the immobile football. When two things can exert force on one another, their interaction can take the form of either pushing or pulling. For instance, two boys are engaging and exerting force on each other in the figure by pulling each other, whereas two girls are interacting and exerting force on each other in the figure by pushing each other. Exploring forces. The strength of a force acting on an item is measured by its magnitude. The SI unit of force, known as Newton, N, is used to measure force magnitude. The amount of force required for a specific activity relies on both the quantity of forces involved and the direction in which they act. Thus, the magnitude and direction of a force can be used to describe it. 1. Two forces acting in the same direction on an object. The amount of force acting on an object. When two forces are acting in the same direction is equal to the total of the net two forces. As a result, pressures exerted in the same direction on an item increase to one another. The two forces' directions of action are the same as the net forces. 2. An object is subjected to two opposing forces. The magnitude of the net force acting on an object when two forces are applied in opposing directions is equal to the sum of the two forces. This net force will move in the greater force's direction. 3. An object is subjected to two equal forces acting in opposition to one another. The net force imposed on the item is 0. If the two forces are equal and applied in opposite directions. In this scenario, the object won't change positions at all. It stays put. In a game of tug-of-war, the rope might not move if two men use precise opposed forces that are at once equal and opposite. 4. A body is being affected by several forces coming from various angles. The magnitude and direction of a force can be used to describe it. 1. Two forces acting in the same direction on an object. The amount of force acting on an object. Effects of force. A force cannot be seen. It can be judged only by the effects it produces on the objects on which it is acting. Force has the following 5 effects on the objects. 1. A force can move a stationary object. When a football player takes a penalty kick in a football match, he applies a force on the stationary football. The force applied by the player makes the stationary football to move towards the goal. 2. A force can stop a moving object. In football match, force applied by a goalkeeper stops the football that is hit towards the goal. 3. A force can change the speed of a moving object. If we push a moving bicycle from behind, then we find that speed of bicycle increases, whereas if we pull a moving bicycle from behind, then the speed of bicycle decreases. If the rider pedals the bicycle faster, then the speed of bicycle increases, and if he applies brakes, the speed of bicycle first decreases and then stops. So we can say that a force can change the speed of a moving object. 4. A force can change the direction of a moving object. When a batsman hits a ball with his bat, he applies force to change the direction of motion of the ball. Similarly, in football match, the players can change the direction of the moving ball by kicking it in different directions. 5. A force can change the shape or size of an object. When we pull a rubber band, it becomes longer. While making chapatis, we change the shape of the dough by applying force with our hands. A potter applies force on the kneaded wet clay to give different shapes and sizes to the pots. So, the application of force on an object may change its shape. Types of force. As we know that, for a force to be effective, two objects must interact with each other. Based on this, forces are categorized as contact or non-contact forces. Contact forces. Contact forces are those in which there is actual physical contact between the two interacting objects. The following are the several types of contact forces. 1. Muscular force. Muscular force is the force that our body's muscles produce. The kind of force known as muscular force is the result of using our physical strength to alter an object's motion. Like when a guy drives a car, his arm muscles are using force. Similarly, a football player's leg muscles are using force when they kick the ball. Human beings uses muscular force for various day-to-day activities such as walking, running, lifting, pushing, stretching, kicking, squeezing, twisting, and many more. 2. Frictional force. Frictional force is a force that consistently opposes an object's relative motion over another object. Only when two surfaces are in direct physical contact does the force of friction start to act. By acting in the opposite direction of the moving object's motion, it slows down or stops objects from moving. For instance, the frictional force between the ground and the ball causes a ball rolling along it to progressively slow down and eventually come to rest. Non-contact forces. Non-contact forces are those that do not require two objects to come into physical touch with one another. Even at a distance, without coming into contact, one thing can exert them on another. The following are the different categories of non-contact forces. 1. Electrostatic force. This is the force that an electrically charged object applies to an equally charged or uncharged object. For instance, when we rub dry hair against a plastic pen, comb, or CD and hold it near little pieces of paper, the paper fragments become drawn to the plastic object. This is because friction causes the plastic object to get electrically charged when we rub it against our dry hair. Currently, the tiny pieces of paper, the uncharged material, are attracted to the electrically charged plastic object when it is brought close to them. Due to this electrostatic force of attraction, the tiny bits of paper move towards the plastic object and stick to it. 2. Magnetic force. A magnet's ability to attract other magnets as well as specific metals like iron, nickel, and cobalt without coming into direct contact with them. For instance, when iron nails are gradually brought close to a magnet, they will abruptly jump in its direction and adhere to it after a few distance. The magnet and the iron nails are not in direct contact in this instance. Magnets attract iron nails to them by applying a magnetic force on them. Depending on which magnet's poles are facing one another, the magnetic force between two magnets positioned close to one another can be either attracting or repulsive. The similar and unlike poles of a magnet repel one another, as we have already seen earlier. You can think of this attraction or repulsion as a push or pull. Consequently, one example of a non-contact force is the force that a magnet applies to another magnet. A magnet's force acting on a piece of iron functions similarly as a non-contact force. 3. Gravitational force. The force that attracts objects to the earth is known as the force of gravity. It has an innate pull to it. For instance, when a ball is tossed above, its descent to the earth is caused by Earth's gravity. Similar to this, the Earth's gravity causes water to constantly flow downward when it comes from a tap. The Earth is not the only object that exhibits gravity. In actuality, every object, big or small, pushes against every other object. We refer to this force as the gravitational force, the force that attracts two bodies that are separated by space in the cosmos is known as the gravitational pull. It is among the universe's primary forces. The mass and distance of the two bodies determine how much gravitational force there is between them. Gravitational force, sometimes known as gravity, is a type of force that operates on things at a distance without coming into contact with one another. Pressure. Try to cut an apple with the help of a knife. Which side of the knife do you use to do this? Now, try to cut the apple with the opposite side of a knife. Is it difficult? Why? How will you be able to push a board pin into the board? By pressing it with the center of your palm or by pressing it with your thumb. You can cut the apple with the sharp edge of the knife and you cannot press a board pin into the board with your palm. This is because the sharp edge of the knife exerts more pressure on the apple and the thumb exerts more pressure on the board pin. Pressure is force applied per unit area. Pressure depends on the magnitude of the force and the area over which it is applied. In the above example, force applied on either side of the knife is same but the area is lesser on the sharp edge than the blunt edge. So, the pressure is more. Similarly, force applied on the board pin with the thumb is over a less area than with the palm, creating more pressure. Pressure can be calculated by the formula. Pressure, P, is equal to force, F, area, A. The unit of pressure can be worked out from the units of force and area. P is equal to Newton per meter raised to the power 2. Is equal to Pascal or N per meter raised to the power 2. Is equal to P, A. Hence, 1 P, A is equal to 1 N per meter raised to the power 2. Pascal is the SI unit of pressure. The CGS unit of pressure is dyne per centimeter raised to the power 2. A bigger unit of pressure is kilopascal. 1 kPa is equal to 1000 Pa. Problem: a force of 1000 N is applied on an area of 5 meter raised to the power 2. Calculate the pressure exerted. Solution: force applied is equal to 1000 N. Area of surface is equal to 5 meter raised to the power 2. Therefore, pressure is equal to force upon area. P is equal to 1000 N upon 5 meter raised to the power 2 is equal to 200 Pa. Pressure in our life. Let us study more about relationship between pressure and area with few examples in our daily life. 1. When carrying large goods, porters cover their heads with a circular piece of fabric. They lessen the strain on their head by doing this, which expands the region on which the weight of the burden falls. They can therefore lift large loads more easily because there is less strain on their heads. 2. The school bag features a wide strap that distributes the weight evenly the children's shoulders, relieving pressure on their shoulders. 3. A sewing needle's point is sharpened to enable it to apply force to a tiny section of fabric, creating a lot of pressure strong enough to pierce the material being sewn. 4. To keep military tankers from sinking in sand or snow, a wide rubber strip is placed over the wheels. Pressure due to air. Air is a mixture of gases. When a gas is enclosed in a container, its particles collide with the walls of the container. The force exerted by the collisions per unit area is called the pressure of the gas. You must have read that for a car to move properly, the tires should have adequate pressure. For this, air is filled into the tubes inside the tires. This air exerts pressure on the wall of the tube and the tire becomes hard. When this tube is pierced by a pointed object, the tire gets deflated and the car is not able to move. A gas always exerts pressure on the surface with which it is in contact. This is because the gas molecules are always moving. While moving, they collide with each other as well as the surface of contact. Atmospheric pressure. The atmosphere is a thick layer of air that surrounds the world. There is an enormous amount of air in the atmosphere. The atmosphere is quite heavy because air has weight. Everything in the atmosphere is under pressure from the weight of the atmosphere. As a result, the pressure that each particle of air in our atmosphere exerts on a surface that is many kilometers above the Earth's surface is known as atmospheric pressure. This pressure is caused by the weight of the air above a surface. Since the particles of air move randomly in all directions, the atmospheric pressure acts in all directions. The air is most dense near the surface of the Earth. As we move higher up in the air, the density of air decreases. Can you guess why? Consequently, the atmospheric pressure is maximum on the surface of the Earth and decreases gradually as we up. This means pressure due to air will be much less at the top of Mount Everest than at the sea level. The pressure exerted by the atmosphere at the sea level is about 101325 Pa. This is also called as 1 atmosphere, 1 atm. 1 atm is equal to 1,01,325 Pa. The instrument used to measure atmospheric pressure is called a barometer. A barometer contains a column of mercury dipped in a container filled with mercury. At 1 atmosphere pressure, the height of the mercury column is 76 centimeters. Application of air pressure. Working of a dropper is filled with a liquid by reducing the pressure inside it. When a dropper is dipped in a liquid and its rubber bulb pressed, the air inside the dropper tube is expelled into the liquid. This reduces the pressure inside the dropper. However, when the bulb is released, the atmospheric pressure acting on the surface of liquid pushes it inside the dropper. Remember, a gas or liquid always moves from a high pressure point to a low pressure point till the pressure at both points become equal. A syringe works on the same principle as the dropper. Our body is able to withstand the strong atmospheric pressure due to balancing the pressure of blood inside our body. In our body, the heart pumps blood into blood vessels at a pressure. The pressure exerted by the blood on the walls of the blood vessels is called blood pressure, and it is slightly higher than the atmospheric pressure. As a result, we do not feel the atmospheric pressure. When a person moves high up in the air or the mountains, the atmospheric pressure decreases a lot but the blood pressure remains same. This may lead to nosebleeds due to rupturing of the blood vessels, pressure due to liquids. Like gases, liquids are also made up of moving particles. So, a liquid also exerts pressure on the walls of its container and any object that is put in it. Pressure in liquids also act in all directions. As an object goes deeper into the water, the weight of the water above it increases. As a result, the pressure also increases. Thus, pressure in liquids increases with depth. When you walk into the water at a swimming pool or in the sea, you feel lighter. This is because of the pressure exerted by the liquid on you upwards. This is called upthrust. You will learn more about upthrust in higher classes. The above activity shows that as we go deeper in water, the pressure increases. For this reason, the deep-sea divers wear special suits that protect their bodies from getting crushed by the pressure of water. Pressure in liquids is measured by a device called manometer. In a nutshell, force is defined as the push or pull on an object. A force has both magnitude and direction. Force can change the speed of an object, the direction of an object's motion, or the shape of an object. When multiple forces act on a body in the same direction, they get added up. When multiple forces act on a body from opposite directions, they get subtracted and the net force is in the direction of the larger force. Contact forces are exerted when two surfaces touch each other. Friction is a contact force that opposes motion. Muscular force is a contact force that moves things. Non-contact force is produced when two objects are near each other but not touching. Magnetic force is a non-contact force in which iron and nickel items are attracted by a magnet. Electrostatic force is a non-contact force of attraction between two oppositely charged bodies. Gravity is a non-contact force due to which an object attracts all other objects around it. Gravity of the Earth is high in magnitude due to its large mass and pulls every object towards its center. Pressure is the force acting on a unit area. Pressure exerted by air is called atmospheric pressure. It decreases as we move up in the air. Pressure exerted by liquids increase with the depth.